Hello children, today I am going to discuss the topic chemical equations and the balancing of chemical equations. We know that a chemical reaction is a process in which new substances with new properties are formed. Let us take an example of a chemical reaction. Zinc reacts with sulfuric acid to form zinc sulfate with the evolution of hydrogen gas. Writing such a long statement to represent a chemical reaction becomes lengthy, takes a lot of time. I can make my job a bit easier by representing it in the form of a word equation. Zinc plus sulfuric acid gives zinc sulfate plus hydrogen gas. But even representing it in the form of a word equation takes time. I can make it more informative, I can make it easier if I can represent this equation, this word equation, in the form of a chemical equation where I am going to represent these elements or the compounds with the help of their symbols or the chemical formula. For example, zinc has got the symbol Zn. Sulfuric acid is represented with the chemical formula Zn, H2SO4. The new compound formed is zinc sulfate, which has the formula ZnSO4, and hydrogen gas is a diatomic molecule, so it has got the formula H2. Same reaction, now it has become more informative, it has become easier for me to write on this equation. Another example, magnesium ribbon burns in air to form magnesium oxide. In the form of a word equation, it will be magnesium plus oxygen gives magnesium oxide. In the form of a chemical equation, the symbol of magnesium is Mg. Oxygen, being a diatomic molecule, is represented as O2, and magnesium oxide is represented with the formula MgO. So what we have done is we have represented the statement in the form of a chemical equation. So how do we define it? Chemical equation. It is a method of representing a chemical reaction with the help of the chemical symbols and the formula of the substances involved in that particular chemical reaction. When we write down these chemical reactions, we find that, let's take an example of magnesium. Mg plus O2 gives MgO. We find that this equation contains unequal number of atoms of one of the element in the reactant and the product side. It has two elements, magnesium and oxygen. The number of atoms on the left hand side that is one atom of magnesium. On the right hand side also there is one atom of magnesium. If we compare oxygen, the left hand side contains two atoms of oxygen while the right hand side contains only one. Such an equation which contains unequal number of atoms of one or more elements in the reactant and the product side is known as unbalanced chemical equation. This equation is also known as skeletal chemical equation. But according to law of conservation of mass, this is not possible. The law of conservation of mass says matter can neither be created nor be destroyed in a chemical reaction. Or we can put it as the mass of reactants is equal to the mass of products, which is possible only if an equation contains equal number of atoms of all the elements which are participating in that particular chemical reaction. Such an equation which contains equal number of atoms of each on the reactant and the product side is known as a balanced chemical equation. Let us take an example. Mg plus O2 gives MgO. Here, the number of atoms of magnesium and oxygen are unequal on the reactant and the product side. To balance the number of atoms on the right hand side, we cannot bring about any change in the chemical formula. What we can do here is, to balance the number of atoms of oxygen, I write here 2. Once I write here 2, on the product side as well as on the reactant side, there are 2 atoms of oxygen. But what is now unbalanced is magnesium. So to balance magnesium, In front of magnesium also I write 2. That means when we carry out this particular reaction, 2 atoms of magnesium react with 1 molecule of oxygen to form 2 molecules of magnesium oxide. Another example, zinc plus dilute hydrochloric acid gives zinc chloride with the evolution of hydrogen gas. The right hand side contains 2 atoms of chlorine and 2 atoms of hydrogen. So to balance this, in front of HCl I write 2, and now the equation is balanced. Children, as we move on, there are certain important points which we need to remember. We need to remember the electronic configuration of the first 20 elements and their valencies, which we have studied in class 9th. We also need to remember the atomicity of the different elements, such as hydrogen, oxygen, nitrogen, chlorine, bromine, and iodine. Each has got the atomicity 2. Hence, hydrogen is represented as H2, oxygen as O2, nitrogen N2, chlorine as Cl2, bromine as Br2, and iodine as I2. For the metals, the atomicity is taken as 1, and for carbon also the atomicity is taken as 1. We also need to revise the names and symbols of the ions which we have done in class 9th. For example, sodium ion is represented as Na positive, potassium as K positive, silver ion as Ag positive, and copper 1 ion as Cu positive. Magnesium Mg dipositive, calcium Ca dipositive, zinc is Zn dipositive, iron 2 is Fe dipositive, copper, which shows copper Roman numeral 2, that is written as Cu2 positive. Aluminium and iron, they both show the valency 3. So iron, when you write down iron 3, it is Fe3 positive, aluminium is Al3 positive. Hydrogen, H positive, hydride, chloride, bromide, and iodide, each carrying the charge -1. Similarly, oxide ion is O2 minus, sulfide ion is S2 minus, nitride ion N3 minus. Ammonium ion is NH4 positive, hydroxide is OH negative, nitrate is NO3 minus. Hydrogen carbonate is HCO3 negative. Carbonate, sulfide and sulfate, they all are di-negative, they all carry di-negative charge. So carbonate is CO3 2 minus, sulfide is SO3 2 minus, while sulfate is SO4 2 minus. And phosphate ion is PO4 3 minus. There are certain elements which show multiple valencies. For example, iron shows the multiple valencies +2 and +3. When it shows a valency +2, we can write it down as iron 2, Roman numeral 2, or ferrous iron, Fe2 positive. Similarly, when iron shows a valency 3 +3, it is written as iron with Roman numeral 3 or ferric iron, Fe tripositive. For the lower valency, we use the term OUS, and for the higher valency, we add IC. Copper also shows two valencies +1 and +2. When it shows the valency +1, it is copper 1 ion or cuprous ion, Cu positive. When it shows the valency +2, it is copper 2 or cupric ion, Cu2 positive. Same is the case with mercury also, +1 and +2, mercurous and mercuric. Mercurous is for Hg positive and mercuric is for Hg dipositive. While writing down the chemical formula of these compounds, you need to be careful which valency we are going to use here. For example, if it is ferrous oxide, ferrous means it is going to take the valency +2. Oxide ion is 2 minus, crisscross, the formula becomes FeO. Ferric oxide, Fe will be 3 positive, oxide ion is 2 minus, so the formula will be Fe2O3. When you write cuprous oxide, cuprous OUS, that means the lower valency of copper. The lower valency of copper is +1, oxide ion is 2 minus. Crisscross, the formula will be Cu2O. When it is cupric oxide, cupric means valency of copper is higher valency of copper, that is 2 plus. Oxide ion is 2 minus, so now the formula becomes CuO. These are certain points which you need to remember while carrying out the balancing of chemical equation. Let me begin with the first example of balancing a chemical equation. The first one is nitrogen and hydrogen combine to form ammonia. First step is to represent it in the form of a word equation. nitrogen plus hydrogen react to form ammonia. Nitrogen being a diatomic molecule, it is represented as N2. Hydrogen is also a diatomic molecule, it is represented as H2. And ammonia is a compound made up of nitrogen and hydrogen. The valency of nitrogen is 3, hydrogen is 1, crisscross, the formula becomes NH3. So the formula of ammonia is NH3. This is the correct skeletal chemical equation or the unbalanced equation. Next step is to balance this particular equation. When you begin the balancing of the equation, select the compound which contains the maximum number of atoms. So this contains 2, this also contains 2, and this is ammonia which contains the maximum number of atoms. NH3. If we check here carefully, it is the nitrogen part that is unbalanced here. So it is N, while on the left hand side it is N2. We can write here 2. When we write here 2, the nitrogen is balanced, but hydrogen is unbalanced. 3 into 2, 6 hydrogen atoms are there on the right hand side. To balance this, I can write 3 in front of hydrogen. So 3 in 3 2s are 6. Now my nitrogen is balanced, hydrogen is balanced. So this is a balanced chemical equation. Let us take another example. Methane burns in air to form carbon dioxide and water. Writing it in the form of a word equation. Methane plus oxygen gives carbon dioxide plus water. Now what is this methane? Children, because it is given burns in air, so burning, for the process of burning, we require oxygen. So whenever you are given burns in air, or whenever you are given a compound undergoes combustion, that means it is going to react with oxygen. Fine. Now what is methane? Methane is a compound made up of carbon and hydrogen. The valency of carbon is 4, hydrogen is 1, crisscross, the formula becomes CH4. This 1 comes at the base of carbon and this 4 comes at the base of hydrogen. So the formula is CH4. Write down the chemical equation. CH4 plus O2. The formula of carbon dioxide is CO2 and water is H2O. Now let us begin the balancing part. Select the compound which contains the maximum number of carbon atom, In this particular case, this is methane, CH4. On the left hand side, there are 4 atoms of hydrogen, while on the right hand side, there are 2. We can balance this by writing here 2. 2 into 2, 4. Hydrogen is now balanced. Now, carbon is already balanced. What we are going to balance now is oxygen. 2 atoms of oxygen plus 2 atoms of oxygen, total making it 4. While on the left hand side, there are only 2 atoms of oxygen. We can balance it. If I can write here 2, 2 into 2 will be 4. Now check carbon, hydrogen, oxygen. Each of the equation is now balanced. So this is another example of balancing of chemical equation. I move on to the next example. That is, iron plus steam gives iron 2,3 oxide with the evolution of hydrogen gas. Iron, it is represented with the symbol Fe. Steam is nothing but water. That is got the formula H2O. Because it is steam, that means it will be in the gaseous state. Now the question arises, what is iron 2,3 oxide? Children, we have discussed that iron shows multiple valencies. If it is 2 oxide, that means it is showing the valency 2 plus, oxide ion 2 minus, so the formula is FeO. Iron 3 oxide, that means it is showing the valency 3 plus, oxide ion 2 minus, that is Fe2O3. So if a compound is showing both the valencies, Fe, That means it is forming a mixture of these two compounds, FeO and Fe2O3, and it is represented as Fe3O4. So the formula of this compound is Fe3O4 plus hydrogen gas, that is H2. Now let us this is the skeletal chemical equation. I can also mention the physical states here. Iron, the physical state is solid. Fe3O4 is also solid, and hydrogen is a gas. Now let me start balancing this particular equation. Select the compound which contains the maximum number of atoms. In this case, it is Fe3O4. I can begin my balancing part with the oxygen atom because this is the one which is containing the maximum number of atoms. So this is O4. To balance this, on the left hand side I write 4. Oxygen is balanced. When I write here 4, oxygen gets balanced but hydrogen gets unbalanced. To balance hydrogen, I am going to write here 4. 4 into 2, 8. 4 into 2, 8. Hydrogen is also balanced. Now the only element which is left out, that is Fe3. To balance this 3, I am going to write here 3. So this is that balanced chemical equation. 3Fe plus 4H2O gives Fe3O4 plus 4H2O. I am going to take the next example of balancing of equation, that is barium chloride plus aluminium sulfate gives barium sulfate plus aluminium chloride. Barium chloride. Barium has got the symbol Ba, chloride ion Cl. With the barium ions have got the charge 2 plus, chloride ion 1 minus. Crisscross, the formula becomes BaCl2. The next compound, that is aluminium sulfate. Aluminium ions 3 plus, sulfate ions 2 minus. Derive the formula becomes Al2SO4 whole thrice. Then comes the next compound, that is BaSO4. Barium sulfate. Barium ions again 2 plus, sulfate ions 2 minus. So the formula becomes BaSO4. And the last one is aluminium chloride. Aluminium chloride, Al ions again 3 plus, chloride ions 1 minus. Derive the formula, this becomes AlCl3. So plus AlCl3. Let me try and balance this. BaCl2 plus Al2SO4 whole thrice gives BaSO4 plus AlCl3. Children, in such case, if this question contains some polyatomic ions, check if the polyatomic ions retain their identity on the right hand side too. You can balance those ions as it is. For example, here sulfate ion SO4, outside the bracket it is 3. So this is a compound which contains the maximum number of atoms. So I'm going to begin my balancing with this particular part. To balance these sulfate ions, I can write here 3. As I do this, the sulfate ions are balanced, but what gets unbalanced is barium. So to balance this, I'm going to write here 3. Now barium is balanced. When I write here 3, the chloride ions become unbalanced. 3 into 2 is 6. On the right hand side, there are only 3 chloride ions. So to balance it, I have to add here 2. When I write here 2, aluminium ions automatically get balanced. So the balanced chemical equation is 3BaCl2 plus Al2SO4 whole thrice gives 3BaSO4 plus 2AlCl3. Check again how we have done it. We began our balancing with the compound containing maximum number of atoms, that is aluminium sulfate, Al2SO4 whole thrice. So to balance these sulfate ions, I have written here 3. Sulfate ions were balanced. As sulfate ion became balanced, now what became unbalanced is barium. So to balance this, on the left hand side in front of BaCl2, I have written 3. Now barium is balanced. Check what happens to chlorine. 3 into 2, 6. On the move to the right hand side, it is AlCl3. So to balance chlorine, I write here 2. When I write here 2, check whether aluminium is balanced. It is 2Al, and on the left hand side also it is Al2. So this particular equation is now balanced. Moving on. Children, after balancing the equation, we can make our equations more informative by mentioning the physical states of the reactants and the products which are participating in that particular chemical reaction. For example, N2 plus H2 gives ammonia, NH3. N2 is a gas, so at the base I can write G. Hydrogen is also a gas, so I can write G. And ammonia is also a gas, so I can write G. We use these symbols. We use S for solid, L for liquid, G for gas, and AQ for aqueous solutions. Aqueous solutions means the solutions which are prepared in water. We can make our equation more informative by writing the concentration of the acid, whether it is dilute or concentrated. For example, zinc when reacts with dilute sulfuric acid gives zinc sulfate aqueous. Zinc sulfate being soluble in water is written as aqueous solution plus hydrogen gas is evolved. Next, we can also show the heat changes taking place during that particular chemical reaction. For example, when carbon burns in presence of oxygen, it forms CO2 gas, plus a large amount of heat is evolved during that particular chemical reaction. Calcium carbonate, when heated strongly, decomposes to form calcium oxide plus carbon dioxide gas. So heat, because heat is to be supplied, it is written on this particular arrow. The last one, that is the conditions under which that particular reaction is taking place. For example, the reaction between nitrogen and hydrogen takes place. You get the maximum yield if you carry out the reaction at 500 degrees Celsius, 200 atmosphere of pressure, and iodide is used as a catalyst. Catalyst is a substance which increases the speed of a reaction and is obtained unchanged at the end of the chemical reaction. So we can make our equations more informative by mentioning their physical state, by mentioning the concentration of the acid, by mentioning the heat changes which are taking place during a chemical reaction, and the conditions under which that particular reaction is taking place. So this is how we can represent or we can convert a chemical reaction into a chemical equation. By balancing it and by mentioning the other details, we can make our equations more informative. Thank you, children. Practice balancing these chemical equations to attain perfection. Thanks a lot.